So hello everyone. Today we are going to discuss A to E1 problems for Codeforces round 890 Div 2. So we are going to discuss the first problem, tails of a sort. तो इस प्रॉब्लम में क्या है? इसमें दिया है कि there is a type of operation where for all we can do one when we apply the operation, what happens is for all I from 1 to n, ai changes to maximum of 0 comma ai minus 1. So this happens basically, and we want that key in the end the array turns out to be like this, non-decreasing. Basically, you can say increasing and non-decreasing basically. मतलब सारे बढ़ने चाहिए आगे आगे जो एलिमेंट्स हो. तो हमें ये ऑपरेशन अप्लाई कर करके ऐसा ट्राई करना है कि हमें ये बताना है कि कब होगा ये. So that is what the answer is. Ki the number of operations Alphan will perform to get such an array. तो सबसे पहला थॉट क्या आता है इसमें? Like, what do you think? किसी का कोई थॉट इस पर? If anyone has a thought, can share, or else I'll tell you the solution. Okay, then. So let's see. Like there is an array like this, something like 3, 1, 6, 7, 2, something like this. Okay. So basically what happens is after each operation, each of the numbers decreases by 1 basically. So what we want is we want that in the end, like a of I is greater than a of I minus 1, greater than equal to a of I minus 1. So one way is like making every element 0, but it is not the optimal solution because there are lesser operations which can result in an increasing array. So for checking that, if we can check for each index that like a of I minus 1 is less than equal to a of I. If this is possible for each index, so we have to see after how many operations is this possible. So हम क्या करेंगे? For each pair, we will see how many operations would it take. So in general, like for each pair, हमें ये भी देखना है ना कि if this is greater than equal to this. So if a of I minus 1 is greater than a of I, then we don't have to do anything, right? But if this, if a of I minus 1 is greater than a of I, then we have to do something. If this is the condition, we don't have to do anything because we have already reached the condition. तो इसमें टर्न होने में लाइक कितने ऑपरेशन लेगा? सो बेसिकली जब ये चीज 0 हो जाएगी ना, तो ऐसा होगा कि दोनों इक्वल हो जाएंगे बिकॉज इट कांट बी लेसर देन 0. लाइक नो नंबर कैन बी लेसर देन 0. तो बेसिकली अगर बड़ा वाला नंबर हम 0 बना दें तो बहुत इजीली पॉसिबल होगा, है ना? तो हमारा जो मेन टारगेट होगा वो यही होगा कि हम जो बड़ा वाला नंबर है, इफ दिस इज द कंडीशन, सो व्हाट विल डू इज विल take the answer is a of I minus 1. So basically we want this for each pair of adjacent indexes, right? So what we will do is we will take the maximum of this. So max of a of I, comma, we will take a variable named answer. Here we will define int answer equal to 0. So if this happens, if this is the condition, so answer equals to maximum of a of I minus 1 comma answer. So if we check the answers for each of them, my bad. Yeah. So like if we check for the first one, so first one is already sorted, so there is not an issue. In this one, what happens is like 2 is greater than 1. So answer is 2 currently. After that also we'll keep on checking adjacent pairs. So here also 2 is greater than 1. So answer remains 2. For this one, first of all, 3 is greater than 1, so answer is 3 currently. After that, 5 is greater than 4, so answer becomes 5, which is the answer here. Here it is already sorted. Here also maximum answer is 4, so 4 is the answer. Here it is 3 because 3 is greater than 1, so 3 is the answer. 4 is less than 5, so 4 can't be the answer and 5 can't be the answer. And yeah, this is how the approach is, and you can see the past solution. It is same Basically, we see if A of I is less than A of I minus 1, then we do this. Simple. Prithvi, you'll get the recording afterwards. It would be uploaded on YouTube. So, I'm moving on to the next question. Good arrays. So, there is an array of positive integers. A array A which has only positive integers, and in a way we define another array B with of positive integers. It is good if and only if A of I is not equal to B of I and the sum of both the arrays are equal. So basically, we want to construct such an array, and we want to know if it is possible or not. Like if we can create an array B such that these are not equal, and the sum of array this is equal to this. So if we if we see what exactly could be the approach, like consider that this is the array. Let us consider that. So basically, you would think that it is possible to make almost like every array. Almost every array is possible to make. But which are the arrays which are not possible to make? Because you can easily tell the probability of like getting an array is very high. Like, but what is the condition when it is not possible? We have to see that. So what is the limitation here? Like we can basically what is the problem here is like for every other number you can decrease and increase, right? If there is 2, you can like put any number 1, 3 or any other number. For whenever there is a 1, but whenever there is a 1, the thing is you have to basically increase the sum. You have to put a bigger number because you can only put positive numbers, so you can't put 0. You have to put 2. So this is the limitation basically. Otherwise, we could have done like +1 in some numbers and -1 in other numbers. This is quite easy. But the only limitation is when there is a 1, we have to put a bigger number. So like let us assume that when A of I equals to 1, we put B of I equal to 2. This is the least possible case that we have to do. So basically what happens is sum increases by 1, right? So for every A of I equal to 1, the thing is sum is currently number of A of I equal to 1. Right? Now, जो बचे हुए number है, the leftover for the leftover numbers, we can decrease the sum basically. The other numbers will help us decrease. But we have to see if the leftover numbers allow that much decrements so that like it is greater than or equal to sum. Basically, if there is a number A of I which is not equal to 1, so how much can we decrease from it? We can decrease A of I minus 1, right? This is the amount of sum we can decrease. So basically, all the numbers which are not equal to 1, we can add this number. We can take another sum, sum negative basically. Negative sum. This is positive sum. We can take it as positive sum. Sum negative plus equal to A of I minus 1, right? For every I, where A of I is not equal to 1. So if this is the case that if sum positive is greater than sum negative, then it is not at all possible for us to make such an array because we have taken the least possible condition, right? We have taken the border condition. We have for 1, we have taken 2. This is the least possible positive sum that we can get, sum pos, and we are taking the maximum possible negative sum we can get. So basically, if this happens, it is no, and for the other case, it is yes. Because if a negative sum is greater than equal to a positive sum, we can obviously make the sums equal. There's no issue in that. So basically, this is the solution. If I can explain you the examples for this question. Yeah. So the first one is 612. So if you can see, there is only one. So if you can, so negative. What is the positive sum? Positive sum is 1. What is the negative sum? 6 minus 1 is 5, and 2 minus 1 is 1. So basically, positive sum is 6, which is sorry, negative sum is 6, which is greater than equal to positive sum. So it is yes for the first case. For the second case, there are 2 ones. So positive sum is 2, right? And negative sum is 0 because there is no number which is not equal to 1. So the answer is no. For this one also, there is the positive sum is 1 and the negative sum is more than 1. You can easily see that. So it is yes. For this one, if you yeah, one more thing, we didn't consider one edge case where n is equal to 1. For n is equal to 1, the thing is you can't make the sum equal because you can't make the elements equal. So it would always be no for n equal to 1. So we have to consider that case separately. And for this one, positive sum is 4 and negative sum is 1, 2 minus 1, 1. So answer is no for this one also. And here it is yes. So if you can see the past solution, it is exactly the same. If a of I equals to 1, x plus plus, and x is my positive sum and y is my negative sum. So y plus equal to a of I minus 1 if it is not equal to 1. And for n equal to 1, I have taken the separate case, and if x is greater than y, then it is no. So this is the solution. If any doubts, you can ask. Else I'll move to the next question. Okay, so I'll move to the next question, which is yeah, any doubt? So to become max, so we are given an array A of length n. In one operation, we can choose an index I so that I is less than equal to n minus 1. Sorry. Okay. So yeah, we can choose an index from in between 1 and n minus 1. So what so yeah, operation works like this. If a of I is less than equal to a of I plus 1, we can increase a of I by 1. And we can apply these operations, and we have to find maximum of all the elements after applying k of these operations. Like we can apply maximum of k operations, and after those k operations, we have to find the maximum of this. So we want the maximum possible value of maximum of the array. If we consider the first example, 133. 133. So, and what is the k? So k here is equal to 4, right? So k is equal to 4. So what we can do is like here a of I, sorry, a of 1 we can increase it by 1 because it is less than equal to a of 2. So we make a of 1 equal to 4 after one operation, and the second one is 3 as it is. Now the thing is we can't increase this one. Like we can't increase it more because it is greater. It is already greater than this one. Now what can we do? We can only increase this one, right? Yeah, we can increase this one. We can't increase this one because it is not allowed. The operation can be applied from 1 to n minus 1. So we try to increase 1 3 times because we won't be able to increase 4 now. We have to increase 1 only. So in the end, it becomes like this. If we take another approach for this, like we don't increase this one, we try to increase this one first. So what happens is after 3 operations, it becomes 4 3 3, right? And after that, one operation is left, but we can't increase it because it is greater than this one. So this is the limitation here. So the answer comes out to be 4 for this question, for this example. Like this, yeah. So the answer is 4 for this one. Now, what would be the approach? What would be the way to approach it? So if you can see the constraints, n is less than equal to 1,000. So we can think that obviously we can apply O of n square solution. We can even apply n square log n solution. But how should we approach it? So the first way that came to my mind was like I'll try to make each of the element maximum. Basically, I'll go to each index and try to make it maximum. The thing is, I'll focus on increasing that element only. So if I focus on increasing that element, I can make that element maximum. So my main focus is to make a particular element maximum. For each element, I'll apply some series of operations. Now, what would be my approach for a particular element? what do I do? Would I have to do? So if I think that I can apply a binary search on answer, because if I apply if I make the number bigger, it would take more operations. That's for sure. So obviously, till some point, a number is possible to be made with the given number of operations. So by binary search, I can find that optimal number, right? So what I'll do is, for each element, and now for each element x. So for that element, I'll apply a binary search on answer. So what would be the endpoints for that? So the least possible maximum for that number is a of basically x itself, and the maximum possible is we can make it 1e9, because the maximum possible answer is 1e8 plus 1e3 basically. So we can safely make it 1e9. So what will happen in binary search? So while L is less than R, so we'll take a mid here, right? So what be the mid? Int m is equal to L plus R by 2. Now for that mid, we have to see basically we make a of I equal to that mid. So basically for each element of index I कर देता हूँ, ठीक है? For index I. So what would happen is I would try to make this element equal to m. So as a result, I would have to make the next element equal to m minus 1. At least m minus 1. Basically, if we see that there is some bunch of numbers 2, 5, 1, 6. If I have to make this number equal to 7, like if I have to make 5 equal to 7, so I would have to make 1 equal to at least 6, right? Because there would come a point where both are 6, then I'll increase it to 7. So I would have to make it at least 6, right? So I have to focus on this. So what I'll do is I'll go to each element from I to j less than n minus 1 j plus plus. I won't consider the last element because last element remains fixed. We can't change the last element. So if so there are two cases basically. If m minus j minus I is greater than a of j, my bad. If this number is greater than a of j, the thing is we have to increase that number. We have to make this number equal to m minus j minus 1, right? So what we can do is we can make another integer which is equal to the number of operations used till now. So what we can do is f plus equal to basically difference of this, right? This. Okay, this is one first condition. What is the second condition? When a of j is already greater than equal to m minus j minus 1. So what would happen in that case? The thing is, in that case, we can easily see that we don't need to increase that number, and we don't need to go beyond, because that number is already greater than equal to m minus j minus 1. So we can make the previous number like greater than that. Like basically we can change the previous number on basis of that. Like consider for this example, if it was 7 instead of 1. So for 5 we can easily make it 8. If we had to make it 7, we can easily make it 7. And now when we come to the next number, we have to make it greater than equal to 6, right? And it is already 7. So we don't even need to do anything after that, because it is already 7. So we can easily increase this number. So what would happen is we will break in this case, right? We would break in this case. So if f is greater than equal to number of operations, less than equal to number of operations permitted, basically the number of operations applied, if number of operations applied is less than equal to this, we can easily make m is inside our answer. So we can make L equal to m plus 1. And in the other case, we can make R equal to m. basically we can make R equal to n minus 1 and L equal to m. That would be better. R equals to m minus 1. But there is an important thing that we are missing. Like, is it really possible to make basically, if we see that the last element is 6, if the last element was 6 and this was a number 2, so is it, if we had to make it 9, if we had to make this number 9, we had to make this number 8. So is it really possible to make this number 8? Is it really possible? It totally depends on this number, because the maximum permissible limit for this number is, if we can easily tell the maximum permissible limit, which is maximum of a of n minus 1 plus 1 comma a of n minus 1, n minus 2 by right. This is the maximum possible value this number can get. Sorry, this number can get, and it should be less than, it should be greater than equal to m minus n minus 2 minus I. Isn't that true? Like, this should be true, right? If this isn't true, basically if this is false, then m is not the answer, right? So if this happens, what we would do is we'll do the same thing as this. R is equal to m minus 1, and we'll apply a continue because we don't want to go further down. So if this happens, we'll do this, because the maximum permissible limit for the second last number is this only, because it depends on this, and this number can't increase. This was the main observation that we had to make. I got a wrong answer on this one because of this case only. I didn't consider this one. So if anyone has any doubts, they can ask. Otherwise, I'll move on to the next question. Okay, so I'll move on to the fourth question. This was a really interesting question. Like, I really like this question. So it is an interactive problem. So what here is given that like there is a permutation of length n, and we can apply an operation where we can pick two integers L and R, where L is less than R. Basically, what it would do is it would tell us the number of inversions of this subarray L to R. So what are the inversions? Inversions is the basically you can read it here. The number of inversions in an array is the number of pairs of indices I comma j such that I is less than j and a of I is greater than j. Basically two numbers such that the previous number is greater than the like further one. So we would get the number of inversions for each of these queries. So we can ask maximum of if we can see like each query costs square of length number of coins. So basically we can spend at most 5n square number of coins. So this is one limitation for the queries. Like, we can't make infinite number of queries, and using these queries we have to find the maximum number in the whole array. So like, what could be the approach for that? Like, actually it is not an easy question. Like, you would have to think a lot before coming to the correct approach. Like, I went through different approaches. I thought of comparing two numbers, like adjacent numbers, and I can figure out if it is increasing or decreasing. Yeah, of course, for two consecutive numbers, I can easily figure out if one is greater than the other or not. But then I thought, can I do it for the two far off numbers? Like, if I have two random numbers, let me consider two random numbers, A and B, two random indices basically. So can I find out which one is greater for two random indices A and B? Can I? So yeah, I figured out an approach to do that. What I can do is I can find the number of inversions in A of A minus 1 comma A plus 1 comma B minus 1. I can do this. I can make one of such operation. it would give me the number of inversions for this subarray. Then I can do a comma b minus 1, and then I can do a plus 1 comma b a plus 1 comma b. So what does let us take it as x, let us take it as y, let us take it as z. So if I need to find out how many numbers are greater less than a, how can I find out? Basically, it is y minus x. Y minus x numbers are less than a in from a plus 1 to b. And if I have to find out for the same for b, if I can find the same for b, basically I'll know which one is greater, right? So if I find that out for b, so if I see what happens is z minus x tells me how many numbers are greater than b, right? Z minus x tells me how many numbers are greater than b, but I want how many numbers the b is greater from. So what I can do is z minus x. I can subtract the z minus x from the total number in this list. So b minus a minus z minus x gives me that number. Gives me the numbers that are less than b. So if I can compare these two numbers basically. I can compare these two and figure out which one is the greater. So yeah. So the answer is yes, I can figure out for two distant numbers which one is greater and not. So I've thought of a divide and conquer approach for this. Like basically, what I'll do is I'll find the maximum for two halves of an array. I can form a recursive function. For that, what I can do is I can take a mid int m equal to I can take here L comma R for general terms. So if m is the mid, what I can do is I can apply a recursion on L comma m and another recursion on m plus 1 comma R. So these are two recursions that I apply. So basically, if this function gives me the maximum answer, so the maximum for the first half is A and maximum for the second half is B, right? These are the two maximums that I have got. So if I have got the maximum for both the halves, I just need to compare these two maximums, right? If I compare these two maximum, my job is done. So I can get the answer through recursive function easily. But I have to figure out the complexity. So what is the complexity for this? So if I see, if I figure out the complexity, so what happens is how many operations, how many coins is it spending? Basically, complex. I want to find out the number of coins it spends. So for a particular, if I see, for a particular n, what happens is it applies three operations, right? So if I do 3 into now how many, what is the length, what would be the length? So I should take the maximum possible length, which is r minus l square. So this is the maximum possible length. So this is the maximum possible coins that could be spent on it. And this is like followed by 2 into t of n by 2, right? So I have to find out what is this t of n, right? So here r minus l is basically the length. So for n, the length is n. For t, basically for the main array, the length is n. So I can do one thing. I can put n square here, 3 into n square plus 2 into t of n by 2. So if I expand the equation, what happens is 3 into n square plus n square by 4 2 into, yeah, basically here 3 into 3 into 3 by 4 basically into 2 also, so 3 by 2 plus n square into 3 by 4 like this. So it becomes a geometric progression. So what I can do is I can find the sum through the formula. So what is the formula? 3 into 1 upon 1 minus 1 by 2. I guess this, yeah, this is the formula. So this turns out to be 6. So it takes a total of 6n square operations. But what is the maximum allowed limit here? 5n square. So the problem is basically it would take more queries than permitted. So it would turn out to be a wrong answer. It would give me a wrong answer. That's what happened with me. Actually, my first solution was based on these three operations. And the problem was that it took more queries. So how can I what number should be that where so that I should decrease the queries? So if I take only 2 queries, what would be my time complexity? So basically this is the number of queries. So I can make it to q, and this is 2 into q. So if I make q equals to 2, it is well within the number of coins allowed. So it would be 4n square. So what I can do is I can use 2 queries, but how can I reduce it to 2 queries? So if I look at the range a comma b, I know for sure that all the numbers between them are less than b and a, less than b or a. Like one, it is less than one of them, right? So if I take the number of inversions in a comma b minus 1, and I take the number of inversions in a comma b. If b is if b is the maximum of the whole array, if I take it as x equal to this and y equal to this, if let us consider that b is the maximum of whole array, so y minus x should be equal to 0 for that. If y minus x equals to 0, b is the maximum of whole array, right? If it isn't equal to 0, b can't be the maximum of whole array. That is for sure, because there is at least one number which is greater than b in this range. If this is not equal to 0, for a maximum number, all the numbers before it should be are obviously less than it. So there is no point in the number of inversions to increase if I do this. So basically, if this is 0, I can consider that b is greater than a. Else, there is no harm in considering a is greater than b. Like it might be possible that a is not greater than b, but it is true that b is not going to be the maximum. So there is a chance that a is maximum. So we can take that chance. Obviously, there is no harm in that. So this would cause us only 2 queries, and it is well within the permissible coins. So we can easily get the answer by this approach. So here we can just apply 2 queries here, and after that we can just return a or b, whichever is the maximum. We'll return a or b, and this is our solution for this. Like it was a pretty good question, and I really like the thought that was put into it. So if I show you my solution, this is my solution. I apply a recursive function for one comma n. Then I take ignore this. I take if I also see if L is equal to R, I return the index itself, and I further do recursive functions, and I basically call 2 queries and see if x minus y is greater than 0, then return a, else I'll return b. So this is my simple solution for this question, and
Jaskaran, hello.
yeah.
एक बार सी समझा सकते हो क्या?
अरे सी जस्ट समझाया था यार.
एक्चुअली नहीं, वो मेरा भी गलत हो गया. एक्चुअली वो ना सिस्टम टेस्टिंग में पास नहीं कर रहा है, आई गेस. एक बार चेक कर लो.
लेट मी सी. ओके, मेरा भी गलत आया.
हाँ भाई, इसीलिए कुछ करना पड़े. एक बार मतलब बता सकते हो क्या क्यों आ रहा है? क्योंकि मेरा भी गलत है, इसलिए मैं आ गया.
हाँ, अच्छा
TCD
अच्छा,
पे.
मुझे भी 1 मिनट सोचना पड़ेगा कि क्यों गलत आ रहा है.
बहुत लोगों का गलत आ रहा है, टू बी ऑनेस्ट.
ओके, लेट मी थिंक क्यों गलत आ सकता है.
एक्चुअली तुम्हारा लॉजिक क्या लगाया था तुमने?
यार मेरा तो बाइनरी सर्च एंड आंसर वाला ही था. लाइक मैंने क्या किया, फॉर हर इंडेक्स के लिए ये देखा कि व्हाट कुड बी द मैक्सिमम पॉसिबल फॉर दैट. and then I applied the binary search and answer and figured out like what is the maximum permissible limit for each integer. Like that I did. एंड एक एक्स्ट्रा कंडीशन ये लगाई थी कि जो सेकंड लास्ट एलिमेंट है उस पे लिमिट क्या है उस पे लगाई थी. तो हाँ मुकुल तुम्हारा सही आया ना तो लाइक व्हाट मतलब व्हाट इज द डिफरेंस इन योर अप्रोच कैन यू टेल मी. अच्छा तो लेट मी सी यार don't know why is it wrong. I think that the problem might be with the limit or something. uh, मुकुल ने कोड तो भेजा है. लेट मी सी. तो जो मुकुल ने कोड भेजा है वो है ये. This is the code that Mukul sent. So let me analyze it. So this is a check function, I guess, index and value for a particular index. What we are doing? Yeah, for each int I equal to 0. Yeah, I less than n minus 1. We are doing this. ARR of I. This and okay. This is the limit. ठीक है. While high is less than low is greater than 1. ठीक है. तो चेक फंक्शन लगाया. ठीक है. तो चेक फंक्शन में आई कॉमा मिड है. तो अभी तक तो सेम ही हमारी अप्रोच. तो फॉर पर्टिकुलर इंडेक्स एंड पर्टिकुलर मिड व्हाट ही इज डूइंग इज सम is he is taking sum as k minus val minus arr of I. Okay. ठीक है. If sum is less than 0 false, of course false है. For int I equal to index plus 1 if I plus 1 equals to n and arr of I is less than val return false. Is then val. Okay. अच्छा val लगा दिया. ठीक है. If arr of I is greater than equal to val break same else sum minus equal to val minus arr of I. If sum is less than 0 return false. यार सिमिलर है अप्रोच मेरी तो. बट
मेरे को भी समझ नहीं आया, मतलब मैं भी
तुमने
कुछ
वन
लोगों
बे
का कोड देख लेता हूँ.
तुमने वन बेस्ड इंडेक्सिंग किया कि जीरो बेस्ड मुकुल. अच्छा जीरो बेस्ड. एक मिनट. तुम कह रहे हो इनिशियल कंडीशन की क्या थी. इनिशियल कंडीशन की थी लास्ट वैल्यू इक्वल्स टू एरर डॉट डार. ओके. हाँ मैंने इनिशियल कंडीशन में हाँ मैंने सारे एलिमेंट्स का मैक्सिमम ले लिया था एक्चुअली. तो दैट्स नॉट एन इशू. लॉन्ग लॉन्ग की दिक्कत तो नहीं आनी चाहिए. एंड उल्टा तुमने एक कंडीशन कम लगाई है इसमें मेरे ख्याल से तो. लाइक सेकेंड लास्ट वैल्यू पे एक कंडीशन होनी चाहिए ना. वो तुमने नहीं लगाई है. लाइक सेकेंड अगर सेकेंड लास्ट एलिमेंट इज ग्रेटर मतलब अगर सेकेंड लास्ट एलिमेंट अपनी मैक्सिमम परमिसिबल लिमिट से लाइक कम हुआ तो मतलब वो वाली कंडीशन नहीं लगाई है तुमने. पता नहीं. चलो बाद में देखते हैं यार. अभी लास्ट क्वेश्चन पर मूव ऑन करता हूँ. अच्छा लाइन 27. अरे ये तो तुमने लास्ट एलिमेंट के लिए लगाया है ना. सेकेंड लास्ट के लिए थोड़ी. तुमने लास्ट एलिमेंट के लिए लगाया ना ये वाला. I was saying कि second last element मेरा actually the thing is जो second last element है ना that उसकी maximum value ये हो सकती है a of n minus 2 comma a of n minus 1 plus 1, so it should be greater than equal to this one. मैंने ये condition लगाई and this should be true, and तुमने ये वाली नहीं लगाई, दूसरी वाली लगाई है. चलो कोई नहीं, अगले क्वेश्चन पर मूव ऑन करता हूँ, बाद में देखते हैं क्या दिक्कत है इसमें. सो ये भी एक अच्छा क्वेश्चन था. लाइक इसमें एक ट्री दे रखा है एंड वी कैन मेक लाइक फॉर ईच of its node we can put a number in that, and that those numbers should be a permutation. So हमें ये बताना है कि like for how many pairs it is true that LCA is in between the values of both the nodes. So बेसिकली अगर हम देखें इसका एक सिंपली जो हमें ये कह रहे हैं, ड्राइंग बना लेता हूँ. तो इसमें जो पेंसिल तो मान लो ऐसा कुछ ट्री है, मान लो ये ट्री है, तो अगर इसको हमें एलसीए बनाना है तो द थिंग इज हम क्या करेंगे, हमें बेसिकली क्या करना है, हमें मैक्सिमम पॉसिबल पेयर्स चाहिए ना. सो व्हाट विल डू इज हियर वी कैन मेक ऑल दीज लेस देन इट एंड दिस वन ग्रेटर देन इट. Basically what we can do is we can make some set of nodes less than and some set of nodes greater than this node. So here there are only like two sets of nodes basically. ये तीन अलग अलग है और ये एक अलग है. The thing is for its particular child any we can't make a pair there. Like एक child में हम दो एक पेयर नहीं बना सकते हैं उसके एक चाइल्ड में, बिकॉज अलग अलग चिल्ड्रन का पार्ट होने चाहिए जो दो हम नोट्स ले रहे हैं. So these three are one group and this one is one group. So 3 into 1, basically the maximum possible is 3 into 1 for this. So 3 for this, and if we want this as the LCA, what is the maximum? 1, 1. So 1 into 1, basically, so the answer is 3 plus 1, 4. 3 for this one, 1 for this one, 0 for this, 0 for this, 0 for this. So if we consider that there are X number of children for this, so the thing is we have to make some set of, basically the thing is ऐसा होगा कि हम पूरे को या तो लेस देन बनाए या ग्रेटर देन बनाए. So that's our choice. So we'll make some of them less than it and some of them greater than it. So what we'll do is we'll add the ones which are less than it and we'll add the ones which are greater than it and we'll multiply both of them. Like for this particular case 1 1 1 3, there are basically four numbers 1 1 1 3. This these numbers are the number of nodes in the subtrees. So 1 1 1 3. So we'll try to make the product maximum. So honestly the product is maximum when the value is this basically we have to divide the sum 6. Basically there are 6 nodes, right? So we have to divide it into the two parts, and we have to divide it into the two parts such that it is closer to the mid like half of that 6, basically 3, as close as it is to the 3 as close as it is to 3 will get the maximum product. So हमें ये फाइंड करना है कि मैक्सिमम प्रोडक्ट कैसे आ सकते हैं. सो इस केस में तो वो सिंपल है, लाइक 1 1 1 का एक ग्रुप एंड 3 का एक ग्रुप. सो 3 into 3 9. तो हम बेसिकली हर नोड के रिकर्सिवली करने ही वाले हैं ये चीज. सो पर हमें ये देखना है कि एक पर्टिकुलर नोड के लिए क्या एल्गोरिथम होना चाहिए उसका. सो इफ वी सी what are the constraints? The constraints are n is less than equal to 5000. So we can apply O of n square algorithm. So what we can do is we can use dp on sum, basically sum dp. So the states is the sum till now, and the value is if that sum is possible or not. So this is the basic DP which is applied in this question. Like yeah, this is the basic DP. So what we can do is we can just for each node we can just list the like number of nodes in each subtree. Like if we consider u as the children for a particular node, so what happens is for each child we put it in a vector int c, right? So we push back c dot push underscore back subtree basically number of nodes num of u. So this would give us the whole array. Now we have to apply a DP. So DP size would be n plus 1. Basically, yeah, we can do it n plus 1, or basically we can do it. We can make it equal to size of subtree, current subtree basically. So this is the maximum permissible limit, right? So for each element, we can do one thing. For auto u of c, we can iterate on the DP basically. Initially, DP of 0 equals to 1 because it is possible. And DP of 1 to n minus, size minus 1 is equal to 0. So here what we'll do is we'll iterate from the back. Because if you iterate from the starting, the problem is like you'll see the problem. Size minus 1 int I equal to j equal to size minus 1. J is greater than equal to 0 and j minus 1. So if u is greater than j, then we have to break it, obviously. And if it is not, what we can do is dp of j or equals to dp of j minus u. Like this is so simple, because if this is possible, then this would be possible. And we are iterating first on the element because each element can come once only. And we are iterating from back because this is unchanged currently. The thing is, if we iterate from the starting, consider that dp of 1 changes from 0 to 1. And after that, we are changing dp of 3. And it also changes to 1 by mistake. Rather, it should have been 0 because of the earlier one. So this is how we apply the DP, and for each of them, we can find the answer. Now, the thing is, you'll think that it is O of NQ. Like it is, it seems that it is O of NQ, like O of N square here, and for DFS also O of N. So you will think that it is O of NQ, but it is not that, because the size of C is, if we sum up the size of C for each of the nodes, it is basically the total number of nodes itself, because it is equal to the number of children, and the number of children are equal to n minus 1 in total. So it is its total time complexity is of n square only. So if any doubts in this question, you can ask.
हेलो
Yeah.
हाँ मैंने भी सेम अप्रोच करी थी, लेकिन उसमें टीएलई आ रहा है, मैं लिंक दे रहा हूँ.
Sure.
ये चैट में दे दी लिंक.
हाँ, कोड कहाँ से 0 है? हाँ सर,
हाँ
मेन तो ये है ना.
हाँ
ठीक है. आंसर प्लस इक्वल टू रिकर्सिव ऑफ i कॉमा c. ठीक है. टर्न डीपी को. ठीक है. मैक्स आंसर में तुमने स्टोर कर रखा है. ठीक है.
हाँ
ओके. तुमने 2D अरे बना रखा है ना इसमें?
हाँ
हाँ, फिर like the thing is, you are making 2D array for each of the node. That is wrong. You are not passing it by reference or something. You are creating it again and again. So O of n cube तो लगेगा ही ना.
ओके, तो फिर कैसे कर सकते थे?
और तुमने इसको यूज कहाँ किया है जो तुमने बनाया? और diff एक मिनट, f फंक्शन f, अच्छा ठीक है।
हाँ वो सबसेट सम का है।
तुम ये कर सकते थे, लाइक फर्स्ट ऑफ ऑल तुम्हारी जो दो स्टेट्स हैं वो क्या है,
एक
इंडेक्स और
सम
वो।
की है, हाँ इंडेक्स और सम की है।
और देखो इंडेक्स की स्टेट मत बनाओ, इंडेक्स पे
हम्म
तो आइटरेट यू कैन आइटरेट ऑन इंडेक्सेस, राइट? यू डोंट नीड अ स्टेट कॉल्ड इंडेक्स, डू यू? बिकॉज प्रीवियस इंडेक्स पे डिपेंडेंट है, इफ यू सी। या हाँ देखो, इंडेक्स पे तो डिपेंडेंट ही नहीं है ना, इज इट?
हम्म, नहीं।
सो यू कैन लिटरली आइटरेट ऑन द इंडाइसेस, राइट?
ओके
तो एक पूरा ये एक स्टेट ही हटा दो, तो उससे तुम्हारी एक तो टाइम कॉम्प्लेक्सिटी बचेगी।
ओके देखता हूँ।
बट स्टिल इफ आई सी, तब भी हाँ ओ एन क्यूब तो नहीं आएगा, ओ एन स्क्वायर ही आ रहा है तब भी। बट आई थिंक तुम बार बार ना लाइक यू आर डिफाइनिंग इट अगेन एंड अगेन, दैट्स व्हाई इन माय केस
अच्छा
आई जस्ट पास्ड इट बाय रेफरेंस, इफ यू सी आई पास
लेकिन
द डीपर ए बाय रेफरेंस।
वेक्टर तो अलग अलग बनेगा ना, मतलब हर वेक्टर के लिए डीपी स्टेट्स तो अलग होंगी ना।
हाँ बट तुम ये कर सकते हो ना, टू सेव द मेमोरी।
मेमोरी लोकेशन का बोल रहे हो क्या?
हाँ मेमोरी सेव करने के लिए ये कर सकते हो, एंड हाँ आई गेस तुम तुम्हारे केस में, इफ आई सी करेक्टली, तो ऐसे लाइक हाँ वन मोर थिंग, लॉन्ग लॉन्ग तुम बार बार लॉन्ग लॉन्ग अरे बना रहे हो, तो दैट
हम्म,
टेक्स अप अ लॉट ऑफ कॉम्प्लेक्सिटी।
अच्छा तो इसको ग्लोबल कर दूं मैं?
हाँ लाइक थोड़ा सा ही फर्क पड़ रहा होगा यार कॉम्प्लेक्सिटी में, बट यही इश्यूज है, एक तो लॉन्ग लॉन्ग एंड यू आर डिफाइनिंग इट अगेन एंड अगेन, सो दैट्स द मेन प्रॉब्लम।
ओके
या हाँ यही है मेनली, ठीक है। तो
ओके
I guess we are done. So thank you. So if you like the video, you can join our DCD server, senior DCD server given in the description. We have the daily contest discussions after every contest. So if you are interested, you can join the link from the server. Thank you.